Yeah. Now in the previous previous lectures, we discussed regarding to refractive index. Now, something more regarding to the refractive index. Once again, I am to recap. That is your incident ray, refracted ray, and emergent ray. So in the previous videos, we discussed about the laws of refraction, and on that time we discussed about the refractive index mu equal to sin I by sin R. What is sin I? Sin I indicating about that sine of angle of incidence and sin R sine of angle of refraction. So refractive index is the ratio between the sine of angle of incidence to the sine of angle of refraction, and this value is constant value. Okay, but that only is not the topic of refractive index. So now I have written here 1, 2, and this is something. What is this something? It is known as mu, M-E-W, mu. So refractive index indicating by this word mu. So here I have written 1 and 2. What is the meaning of this one? So the meaning of this 1, 2 is refractive index of medium 2 with respect to 1. So here I have written here speed of medium 1 and speed of in medium 2. That is speed of what? Light. Speed of light in medium 1 with the speed of light in medium 2 is indicating about that mu 1, 2. Once again, how to read it? Refractive index of second medium with respect to first medium. Right? Now, once again I have written here mu CV means what? Refractive index of what? Refractive index of medium 2 with 1 means V with C. So that means speed of light in vacuum or air. C means speed of light in air or vacuum, and here speed of light in that medium, that is V. So this is called absolute refractive index. It is considered as absolute refractive index. Okay. Now these are the basic concepts of the refractive index. So any one of the definitions you can write, but if it is mentioned define absolute refractive index, then you must have to write the speed of light in vacuum or air to the speed of light in that medium. So how to calculate it now? It is your C and it is V. So refractive index C upon V. C means what? At the beginning I said what? C equal to lambda into frequency. So lambda into F, and V lambda dash into F. Frequency does not change. Frequency does not change, right? So F to F cancel. Mu equal to lambda upon lambda dash. So now, have you think something regarding to this one? What I said at the beginning, if light travel from rarer medium to denser medium, speed decreases. And again I said, if light travel from denser medium to rarer medium, speed increases. So how it is effective? How it is effective? Here I have written here sin I by sin R. So that means if speed decreases, wavelength decreases, and then refractive index increases. If speed increases, wavelength increases, and thus refractive index increases. So by using this concept, you can say refractive index is the reciprocal of refractive index is lambda into 1 upon lambda dash. Means it is the reciprocal. This is lambda of light in air, and lambda dash is the speed of wavelength in given medium. So wavelength decreases, refractive index increases. Wavelength increases, refractive index decreases. Just reverse, reciprocal, right? So on this concept, you can see refractive index is affecting by wavelength. More the wavelength, in your syllabus it is always considered as wavelength. Instead of wavelength, they are going to write color. So it's a little bit confusing word. So please try to think only about the wavelength. Don't learn about the color. Only consider in your mind that is wavelength. Right. So once again, so refractive index, what is the cause of the refractive index? Now you understood what is the cause of refractive index. First cause, to think about it. Refractive index based on speed of light. Right. Speed of light increases, refractive index decreases. Speed of light decreases, refractive index increase, right? So that means it is just reciprocal, right? So laws of refraction, you know about the refractive index, you all know. Now one other thing is lateral displacement. See, if I just imagine like this line increase. Now you can see here that angle, perpendicular distance. So the perpendicular distance between emergent ray and the ray, incident ray which produced. The perpendicular distance between emergent ray and the incident ray which is produced is called lateral displacement. This is lateral displacement. Naturally, it depends on thickness. If suppose you are going to take thicker glass slab, right? What will happen then? It will naturally increase. It also depends on the wavelength, right? More the density, then less the refractive index. Less the refractive index, lateral displacement increases. So these all are the basic concepts of refraction of light. Something more related to all these things we all will discuss in the next videos, and hope you understood the concept of refractive index and refraction of light. Now in the next videos we will discuss regarding to critical angle, which is an important parts of the refraction of light. Thank you very much.